This is Algebra 2, Chapter 2, Section 1, in which we will further our study of relations and functions. We talked in Chapter 0 about what a relation is, specifically that it's a grouping of ordered pairs so that the members of the domain get paired to the members of the range. We then talked about functions that are special kinds of relations, so that each element in the domain is paired to exactly one element in the range. Well, now we're going to expand on that idea. We're going to talk about some subcategories of functions, the first of which is called a one-to-one function. In a one-to-one function, not only do the members of the domain have exactly one partner from the range, but it also means that each part of the range has exactly one partner back in the domain. Another way to say that is no two parts of the domain have the same value in the range. Another kind of function is called the onto function. An onto function is one in which every member of the range is utilized. Every member of the range has a corresponding partner back in the domain. You don't skip anything. Now, it's possible to have a function that's just one-to-one. It's possible to have it be just onto. It could be both one-to-one and onto, or it could be neither one. And we're going to look at some examples of those ideas. So they're going to ask us to decide what the domain and range are for a given relation, decide if it's a function or not, and then decide what kind of function it is. Well, domain and range should be easy, because we remember how to do that. Domain is all the x's, so -6, -5, -3, -1, and 6. The range is all of the y's, -1, -9, -7, and 7. I did not name the -9 the second time because it's already been named. Well, let's take a look. Does everything in the domain have exactly one partner? -6 has exactly one partner. -5 has exactly one partner. -3 does, -1 does, and 6 does. So this is indeed a function. Now we need to decide if it's one-to-one or not. To be one-to-one, every member of the range has to have exactly one partner back in the domain. -9 has a partner of -5, but it also is partnered back with 6. So this is not a one-to-one function. In an onto function, everything in the range is used. Is every member of the range being used here? Yes, everything that's listed in the range is used, so it is indeed onto. It can't be both, because in this case, because we said it wasn't one-to-one. And it's not a neither function because it was onto, so onto is the only one we can use here. Now, one other idea they're going to throw at us is the idea of what kind of function, what kind of graph we're looking at. If we have a graph that's made of just individual points, they're not connected in any way, they're just dot, 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 then that kind of graph has a special name. It's called a discrete graph. That's when it's just a series of dots that are not connected in any way. If we connect the points, if our graph is a connected graph, then it's called a continuous graph or a continuous function. So they're going to ask us to make a graph of y equals half x minus 3. They want us to determine whether we have a function or not, and then what kind of function if it is a function, and then is it discrete or is it continuous. Well, to start with, we need to make a table, get some points, and I kind of already have done that for us. I know that the y-intercept is negative 3, so I started at negative 3. The slope is 1/2. Well, I remember slope means rise over run. So from the point that we started at, negative 3, rise 1, run 2, and that gives me my line. Now, since this is a line and not just a series of dots that aren't connected, this is a continuous function. I can say that for sure. Nowhere do the x's get repeated. That is to say that at x equals negative 3, there's one answer. At x equals negative 2, there's one answer. At every x along the way, there's only one answer. So this is a function. In this case, it is also a one-to-one function because nowhere do you have two different values for x along any y. Okay, at y equals 1, there's only 1 point. At y equals 2, there's only 1 point. At y equals 0, at y equals negative 1, y equals negative 2, and so forth. There's only 1 point for any given y, so it's one-to-one. The whole range is being used. There's no gaps. So this one is both one-to-one and onto. Okay. And our last idea is to get used to the idea of function notation. Okay, they're going to give us a function. F of x equals 2x squared minus 8 in this case. What this tells me is that whatever value of x I have, I plug into this equation over here, 2x squared minus 8, and I get a value for y. Whatever x they're giving me gets plugged in. So here they're saying f of 3. Now, very important to note that this is not f times 3. This is f of 3. There's no multiplication going on here. This is saying the function at a value of x equals 3. Well, if x equals 3, we're going to plug that in. 2 times 3 squared minus 8. Now we have to excuse our dear Aunt Sally. 3 squared is 9. 2 times 9 is 18 minus 8 gives us an answer of 10. Now, again, I'm going to stress this. It's kind of an important idea here. I'm not dividing by this 3 back here. This is not f times 3, so I don't need to divide to get to f equals. The function, when evaluated at x equals 3, gives me a value of 10. Now, it's also important to notice here, there's no rule that says it has to be a number that we're plugging into the function. We can plug anything into the function that we need to. In this case, we're going to plug in 2a. The function evaluated at 2a. So I'm going to put 2a in place of x, which means I'm going to have 2 times 2a squared minus 8. Now we're evaluating this at 2a. We excuse our dear Aunt Sally. 2a squared, 2a quantity squared, is 2a times 2a, which is 4a squared. 4a squared times 2 is 8a squared minus 8. They're not alike terms. We can't collect them. So that's as far as we can go. Many times students get confused at this point and say, but what's the answer? The answer is 8a squared minus 8. We don't have a value for a. We're stuck at this point. So now we have one more problem, the function evaluated at c minus 1. Well, this means, hopefully you've picked up on this, that x is equal to c minus 1. So I'm going to put c minus 1 in place of x. 2 times c minus 1 squared minus 8. Now here's another point where people tend to make a mistake. They see this c minus 1 squared and they think it becomes c squared plus 1 because they square both of them. That's not the case. You need to remind yourself what it means to be squared. Squared means times itself. So I took c minus 1 times c minus 1 and distributed and got c squared minus 2c plus 1. I've still got 2 times this quantity, so I need to distribute the 2. And then I can collect the 2 and the negative 8, and I end up with 2c squared minus 4c minus 6. Okay. That kind of problem is filled with possible danger points because people don't keep in mind what it means to be squared. And they try to just square both parts and call it good. You have to remember to distribute out the square. C minus 1 squared means c minus 1 times c minus 1. So we've talked about the different kinds of functions, onto, one-to-one, both, and neither. We've talked about continuous and discrete graphs and the difference between those. And then we looked into function notation, which amounted to plugging and chugging. And as always, if you had questions along the way, I hope you wrote those down, bring them in with you, and we will see you in class.